Now, if you're a teacher, you need to stay to the end of the video because I got some messages for you about, well, this lesson. We're going to talk about inequalities today. Now, if you're a student, I would highly suggest that you have your finger on the pause button and you've got your notes, pencil, all that stuff ready to go because, well, you can't be passive and really expect to learn. Now, this is how it's going to work. I'm going to introduce the concept and I'm going to ask you some questions. So when a question is being asked, you need to pause the video and, well, see if you can answer the question, and then you're going to see if you're right or not. Because no matter how well the concept is introduced, you're going to have some misunderstandings, right? And so then when we talk about your answers, we're going to revert the things that you maybe misunderstood back to the concept, and through all of that, we're going to develop some procedures. That's how it works. This is the best way to learn. I mean, this is super effective. Then when we're done with the whole video, you're going to have a pretty good understanding of how things work. You're going to be doing some other problems that might confuse you a little bit further, and then we'll come back to those in another video and, well, deepen our understanding and make you even much more of a math pimp. That is P-I-M-P. Anyway, let's get started. Math is all about describing relationships. And most of the time we talk about things that are equal. But in reality, most things are not equal. Usually one thing's bigger than another. You know, like A would be bigger than B. And the relationships absolutely matter. Now, math is a language, and we use symbols to convey meaning between people, right? This symbol right here is, well, that's called greater than. It's an inequality symbol. It's a strict inequality. It says A is bigger than B. And, well, the other way would be also true that B could be bigger, right? And so if A was smaller than B, we would use this. This is the less than symbol. Now, man, language is tricky because you can say the same thing in different ways. The words are going to be different, but the meaning will be the same. So these two here on the left, A is less than B. It's the same as B is greater than A. So let's see how this works with some numbers and some unknowns. Now, X is just a number, right? It says X is less than 4. So how big could X be? Common guess, like this guy over here, his name's Bobbert. Common guess from people like Bobbert is, well, it could be 4, right? Jessica over here on the left, she doesn't like that. Jessica says, well, 4 can't be less than 4. That doesn't make any sense. 4 is equal to 4. That's kind of confusing, I know, right? So X can't be 4. It has to be less than 4. Like 3. 3, right? Now remember, we're trying to figure out what's the biggest answer, and 3 is a very common answer. And it's true, 3 is less than 4, but there's a lot of numbers that are bigger than 3 leading up to 4, right? So another common answer is, well, 3.9 then, right? 3.9 repeating. Well, about that. That's kind of confusing. I mean, like, this is a pretty confusing question. Which one of these is red? Just depends on what it is you're looking at, right? So without chasing this too far, 3.9 repeating is 3 plus 0.9 repeating. And the 0.9 repeating, well, that's equal to 1/3 plus 1/3 plus 1/3. That's only a repeating decimal because 3 doesn't play nice with 10. And we use base 10 math. So it turns out that 0.9 repeating actually is 1. So 3.9 repeating is 4. That might be frustrating and confusing, but that actually kind of shows us the power of actually making a graph, because we can't actually write the biggest number out, but we could draw a picture of it, and that's what that circle means right there. That circle, very, very important. We put a circle around the number that is, well, almost the biggest answer. It can't quite be 4, so we go all the way up to 4, but 4 is not included, and everything smaller than that, well, would be a value for X. Would make this true. So what we're doing with the graph is we're drawing a picture of all of the answers, all of the things that X could equal that would make this a true statement. And, well, there are infinitely many answers, right? Yep, infinitely many. Now, a big idea here is that infinity isn't a number. It's just a concept. Like, we could keep finding smaller and smaller and smaller answers to this, right? So now what if we used a solid dot instead of a circle? What that would mean is that X would be less than or equal to 4. That's fundamentally different because here the biggest answer for X is 4 because 4 is less than or equal to 4. Yeah, well, so a little different right there. Now, if we didn't want to make a graph, we could actually write our answers out. But we couldn't list all of the answers, but there's this thing called set notation that lets us write a list of answers by just showing the smallest and the largest answer. So if we start with the smallest answer, well, there isn't one. It's negative infinity, but that's not negative 1 times infinity because, well, infinity is not a number. It just means that there's not a smallest answer. So we start with negative infinity, and it goes all the way up to 4. Do you see? Now, over here, the 4 is included, right? And the way we're going to write the notation is that all the numbers in between, like the smallest number you can think of all the way up to 4 would be included. So what we're going to do is we're going to write negative infinity, comma, 4. Now the square bracket means the 4 is part of the answer because it could be equal to. And the curve means that this number right next to the curve, well, is not included. And negative infinity is not included because it's not a number. Well, this one over here, to show you the difference, this curve right here, what this means is that 4 is not included. It means we go all the way up to, but not including 4. So starting with the smallest number you can think of, all the way up to, but not including 4. And, well, yeah, so here we go. Let's take a look at how we write these things again. If we have a strict inequality on a graph, we're going to use a circle. And strict inequalities are these symbols here. It is strictly less than or strictly greater than. And in set notation, we use parentheses with a comma. Now, one note, they look like coordinates, locations on a graph, and they're kind of similar to that, but contextually they're quite a bit different because we're talking about all the numbers in between the two numbers in the set. Now, if it's a non-strict inequality, which means it could be equal to, we would use a solid dot, and we would use these brackets. All right, so let's try some. Let's graph this one right here. Bobbert is like, I'm on it. You pause the video, you try it, see how we do. Okay, so Bobbert's like, well, 3 is, yeah, it's right there. So this is less than or equal to 3, and boom, done. Right? Jessica's not so happy. She's like, why did you draw it to the left? And of course he drew it to the left because of that arrow, right? It looks like it's pointing left. And he was taught that before, but that's not actually true. You see, the graph's supposed to be a picture of all the answers, and 0 right here should be an answer according to this graph. 0 is part of this graph, but if I put 0 in, I get a false statement. 3 is not less than 0. 0, So 0 is smaller than 3. 3 is bigger than 0. This doesn't quite make sense. The thing is, you can't just look at this. This doesn't point in the direction that the graph goes. Sometimes it does, but not always. This is a statement. You have to read it. This says 3 is less than x. That's also the same as x is greater than 3. X is greater than 3. All the numbers that are bigger than 3 are the answers. You see, again, you can say the same statement in two different ways. I'm shorter than you, or you're taller than me. Now, let's try another one. 3 is greater than or equal to x plus 1. Dang. You go ahead and try it. I know I haven't taught you any steps yet, but give it a shot. Now, here's how we're going to do this. I will teach you some steps for these kinds of problems in just a moment, but not yet. Let's go ahead and start off, though, by just trying a number, seeing if it works, because this is how you know you're going to be right when you're done anyway. So let's try 5. Would 5 work? If I put a 5 in there, I get 3 is greater than or equal to 6. 3 is not bigger than 6, so that would not be an answer. 5 will not be a dot on my graph. Yeah. All right, well, let's try another one. Let's try 0. 0 does work. 3 is greater than 0 plus 1, so there's going to be a dot on the 0 for sure. In fact, all of the negative numbers are going to work. Everything less than 0 will be a solution. So I could put dots on every single negative number, or I could just draw a line, because that's what lines are. Lines mean that every single thing underneath that line is an answer. And actually, if you were to try to draw a dot on every single negative number, it would form a solid line, continuous with no gaps at all. So anyway, now let's look at some other solutions. Let's see if we can find the biggest solution. And I know that's confusing, but take a minute. Think about it. What do you think it is? Well, let's try 1. Is 1 an answer? Well, 1 plus 1 is 2, and 3. 3 is bigger than 2, so 1 is an answer. And, well, let's try 2. 2 plus 1 is 3. 3 is greater than or equal to 3. Wait, is that true? You see, greater than or equal to. Well, one of those two parts has to be true. Is 3 greater than 3? No, but or means, is it maybe then equal to 3? Greater than or equal to? So since 3 is equal to 3, yeah, that's an answer right there. That's on our graph. Now 4 doesn't work and 3 doesn't work because, well, how would they? If it was 4 is already bigger than 3. If I'm adding something to it, then that wouldn't work. Looks like 2 is the biggest answer. So we think that maybe this is our answer right here, from negative infinity all the way up to and including 2. Now, just to make sure, let's try something just slightly bigger than 2, like 2.1. If I have 2.1 and I add 1 to it, I get 3.1. That's bigger than 3. Because 2 plus 1 equals 3, and then this number over here can't be bigger. It has to be less than or equal to the number 3. Nothing bigger than 2 would work. So this is right. Now, let's try this one right here. You go ahead and try it. So once you've tried it, go ahead and push play again, and let's see how this works. The first thing we got to figure out, though, what's the biggest or maybe the smallest answer? Where does the dot go? Or the circle in this case, because it's a strict inequality. And the way we can do that is we can actually use some algebra. We can treat this just like an equation. The only thing that's different is if we have to multiply or divide by a negative. We'll get to that in just a minute. So this right here, it says 2 times what? Plus 1 is 7. Well, what plus 1 is 7? Well, 6, right? 6 plus 1 is 7. So this 2 times x was, well, it's going to be equal to 6. So what times 2 is 6? Well, 3, right? 2 times 3 is 6. So x is less than 3. So x is less than 3. And that means we're going to have an open circle on 3 because 3 almost is the answer. All the way up to, but not including 3. Now we just have to figure out which way do we shade. Is it going to go to the left? Or is it going to go to the right? Because either all the answers are over here less than 3, or they're all over here more than 3. Now this says x is less than 3, so I think we're going to go to the left, because these numbers all over here are less than the number 3. Now sometimes it's a little complicated though. Some of these problems do get complicated, and you actually might want to take a number on each side and plug it in. So like this, right here. You could probably do this one in your head, right? We're going to take 2 and see if the numbers to the left are the answers. 2 times 2 is 4, plus 1 is 5. 5 is less than 7. That works. Whereas 4 doesn't work because that gives us 9. 9 is not less than 7. So this works over here. So we shade it that direction because the solutions are all over there. So we get negative infinity all the way up to, but not including 3 once again. Now, last example that we're going to try to solve and graph right here. 1 minus 2x is less than 7. This one's really tricky. Let's go ahead and talk about some algebraic steps right here. Inverse operations. You see this 1 right here, it turns out it's actually positive. Doesn't look like it, but it is. There's an invisible positive sign right in front of it. People always mess it up. They say, oh, well, this negative means I have to, well, that 1 is negative, so I'd have to add 1 to both sides, but that would actually make this equal to 2, not 0. Well, negative 1 plus 1 is 0, and if I subtract 1 from the left, in order to maintain this balance, I'd have to subtract 1 also from the right. So I'd end up with negative 2 times x is less than 6. Well, I think this is going to be 3, a negative 3, right? Because negative 2 times negative 3 would be 6. Well, if I wanted to write out my steps, I would go ahead and just divide by negative 2. A negative divided by a negative is positive. A positive divided by a negative is negative. And, well, remember how I said we have to do one little thing different if you multiply or divide by a negative, and that's you have to switch the sign. And that's because negatives means opposite. We have changed the relationship. We've done the opposite relationship, so we do have to switch the sign. So let's go ahead and see if that's really true, right? Let's see if we have a right answer. Let's see if 0 would work. 0 is bigger than negative 3, right? It is. 0 is bigger than negative 3, so let's plug in 0 here and see if that's really true. So I got 2 times 0. So 1 minus 2 times 0. Well, 2 times 0 is 0. 1 less than 7. That is true. We found the answers. That's pretty cool. Now, you try this. Write an inequality that matches this solution set. And no, I haven't shown you how to do it, but if you understand what this really means, You can work your way through it. It might take you a couple minutes, but it's no big deal. Go ahead and pause the video and give it a shot. All right, now Jessica's like, I'll help you out. Let's start with a number line, and let's put our two numbers on the number line. We have -4 and 9. Oh yeah, do you see how that works? -4, it's going to be a solid dot because of this, and 9 is going to be an open circle because of the curved bracket, the parentheses, right? And if you remember, this means all the answers are in between -4 and 9. So like, 5 and 0 and -3 and 2, all those numbers would be part of our answer. This says that x is bigger than or equal to -4. And the confusing part, though, is that at the same time, x is also less than 9. So I need to write a single statement that says that x is bigger than -4, but x is also less than 9. Oh yeah, do you remember? You can say statements in more than one direction, right? Like you can change the direction of the statement around just by changing the words. So we could say, instead of saying x is greater than or equal to -4, you could say -4 is less than or equal to x. And at the same time, x is less than 9. Pretty interesting. Well, I hope this was helpful and informative. Let me know what questions you have. Just leave me a comment down below. We have introduced the concept and tried some practice problems, and I hope I've uncovered some misconceptions and replaced those with correct understanding. It's now up to you. The next steps are yours. There's some practice problems that I'm going to show you right now, and then in a next video, we will talk about those questions. And hopefully, between all that, you will be rock solid and be nailing your classes, but in a way that not just you're passing this test, but you're also developing some mathematical habits that, well, make math a lot easier for you in the future, even with topics that have nothing to do with inequalities. So anyway, here are the practice problems. Go ahead and give them a shot, and then let me know how it went. So I hope this video helped. If it did, you could really help me out just clicking like and maybe subscribing. And if you're curious about this, or other topics, you could visit my website, thebeardedmathman.com. So anyway, I'd like to thank you for your time, and I hope you have a good day. So teachers, my goal, my mission in life is to help with mathematical education. I think that we are not doing a very good job for our students, and it's not really our fault. There's not a lot of quality materials out there. Everything is, well, the majority of things seem to be a top-down fashion, like here are the facts, learn them, and that's not really how we learn. So I'm making this PowerPoint available to you. I'll put a link in the description down below, and here's what I just want to take just a quick moment to run you through how it works. You see, in the PowerPoint, each slide has some notes about what's happening and when, and the things that the ideas that I'm trying to share as the PowerPoint, as you would move through the PowerPoint. You could download it and use it in your classes. You could change what you like. You could put bell work. You could make this. I would probably make this into several days worth of lessons, but there's a lot of things that are good structurally here for you. And yeah, anyway, I want to help out. I would hope this would be something you could use. So for example, though, on this part right here, after this graphing, I would probably put some practice problems in there and have the students practice graphing. And, just without having to do any solving. And maybe I'll give them a graph and ask them to write down the inequality that would match the graph. And then as we move through and we get a little bit more complicated, I would maybe have them practice some problems, that just don't really quite fit in with the video. So anyway, my name is Philip Brown, and I really do hope this was helpful. If it was, let me know. Leave me a comment in the description, or leave me a comment down below. And as always, there is a lot of help that I'm producing and a lot of materials I'm producing that are being published on my website, thebeardedmathman.com. Anyway, I hope this video was helpful, and I want to thank you once again for your time. And if there's something you need help with, or a topic you're having a difficult time teaching, let me know. I've been teaching for quite a while, and I've taught just about everything that there is, calculus and below, and I might have some good ideas that I'd be very willing and happy to share with you. So anyway, once again, thank you for your time, and I hope you have a great day.